All right. So let's go ahead and let's summarize like the formula that we need to know. So we're going to say that to write our integral, we have the value from a to b. And this first one, this is going to be for the disk method. That's all the video was the disk method, but there's two methods. There's disk and washer, and we're going to do the washer method partway through class. So the disk method has, like, you find your little area, and as you rotate it around the axis, what shape does it form? A circle, because it's going all the way around the axis, right? And it's an equal distance around the axis as it makes that swivel, okay? So that means that the function itself, if we do top minus bottom, that value itself is the radius of the circle that it's making, okay? So we're going to say that what we're integrating is pi r squared, pi times radius squared, because that's the area of a circle. And the r value is going to be top minus bottom if it's a dx, if everything's in terms of x. Or it's going to be from a to b of pi times right minus left squared if it's in terms of y. So do you see how similar this is to what we've already been working with? Yeah. Okay, so we're still remembering top minus bottom for x's and right minus left for y's. But now we're talking about making a volume, about rotating something around. So this is actually a unit where I'd maybe like make my cheat sheet as I go, because I like to have it out while I'm working on it. It helps me to have this in front of my face. Okay, so for this one we have the equation y equals negative x plus 2, and that's what we're going to draw first. So what should that look like? It's linear. It has a y-intercept at 2 and a slope of, so it goes down 1, right 1, down 1, right 1. Okay. And then what other lines are we going to draw? Okay, so x equals 0 is the y-axis. Y equals 0 is the x-axis. So that means that the shape that we have is this right here. And what did the instructions say about the axis that we're rotating it around? We are rotating it around the x-axis. So if we are rotating it this way, is it in terms of x or is it in terms of y? Okay, so we're going to say rotate around x-axis, would make it in terms of x. Rotate around y-axis makes it in terms of y. Okay. So what is my interval going to be? 0 to 2. That one I didn't even need to really think about it too much. So 0 right here, 2 right there. And if I do top, I've got pi r squared, right? So pi times r squared dx. If I do top minus bottom, what do I have? Plus 2 minus, what's the bottom? 0. Okay. The reason I'm going to put that bottom of 0 in there is because if we start to rotate this around something other than the axis, it's going to change that number. Okay, so right now it's the x-axis, that means we just have 0, but if it was something else, it would change. Okay, and we're going to go ahead and do this completely by hand. They want our answer in terms of pi, which means we got to do it by hand. So typically what people do when they do these problems is they just take the pi and they move it to the front so they don't have to mess with it. So I'm going to say this is from 0 to 2, put the pi in the front. I have the function negative x plus 2 squared dx. And I've got two options. I could FOIL this out before I take the antiderivative, or I could do U substitution. U substitution? Okay. So what would my inside be? Okay, U is negative x plus 2. What is du? Dx, okay. Divide by the negative 1. So we have that this is our u, and then our dx is going to be du over negative 1. Okay, so I'm going to take my negative 1 and move it to the front with the pi. And I've got u squared du, and since I'm in terms of u, I have to change my interval. So u in terms, u with 2 plugged in would be negative 2 plus 2 is 0. U with 0 plugged in, negative 0 plus 2, which is 2. Okay. All right, so how do we do this by hand? Plus 1, divide by 3. So I have 1/3 u to the third. And don't forget we have that negative pi in the front. I almost forgot. And this is evaluated from 0 to 2. So we have negative pi times 1/3 times 0 cubed minus 1/3 times 2 cubed. And this is nothing. So we have negative pi times negative 8/3. And so our answer is 8 pi over 3. And if I want to double check my answer, from 0 to 2 of negative x plus 2 squared Okay, so I did pi r squared. I'm just typing that in, pi r squared. And I got my decimals, and I'm going to type in 8 pi over 3, and they're the same, so I got it right. Sound good? Okay. Shall we do another one? Yeah. Okay. Do you guys want to do 2, 3, or 4? 4? Okay. Like this one, actually I can just show you what it would have looked like because I foiled it out on my answer key so you can see it. So what I did here is I just foiled it, so that gave me x squared minus 4x plus 4. And then when I did it, I just used those little antiderivative rules on all three. And I never did a u substitution. So it works out like steps-wise, it's about the same number of steps.
So if we don't do the substitution, we keep the interval as it is?
Mm-hmm. Mm-hmm. Okay. All right, number 4. All right, with this one, if we're going to graph it by hand, you might not recognize this, so I'm going to show you, and then you might remember it in the future. So I'm going to take the equation y equals the square root of 9 minus x squared, and I'm going to square both sides. Why am I doing that? Get rid of the square root. So y squared equals 9 minus x squared. And then I'm going to go ahead and add the x squared to the left side. And the reason I'm doing that is because it gave me x squared plus y squared equals 9. Do you recognize what that is? It's a circle. Centered where? Centered at 0, 0 with a radius of 3. So what this is right here is this is the calculator-friendly version of a circle where you can plug it in. It's a function. It doesn't have a plus minus. It's just the positive version. It's only the top half of the circle.
So how would it be if we would draw the whole thing?
You would be wrong because it's only supposed to be the top part. You know that because it's only the positive square root.
Okay.
The bottom of the circle would be the negative square root. And it says that it's the part where x is greater than or equal to 0, and then above the x-axis, right? So here's the y equals 0 line, and then here's the x equals 0 line. And the reason they said the x is greater than or equal to 0 is because they want you to use the right side that's bounded, not the left side. So that's why they said, they didn't just say x equals 0, because that wouldn't really help you. They said that where x is greater than 0, because they're telling you to use this part right here. Yes?
I'm sorry, why is it a half circle again?
It's a half circle because it's the positive square root, not plus and minus. Mm-hmm. All right, so what is our interval? Yeah, 0 to 3, because that's the radius. And we have pi r squared, and the r value is going to be top minus bottom. So what's the top? Square root of 9 minus x squared. Minus, what's the bottom? 0. So I'm going to go ahead and move the pi to the front. What happens when you square what's in the parentheses? The square root goes away. So this one, instead of thinking of this as a u substitution, so this is saying what area are we making? And the area we're making is that circle. All right, so pi r squared, this one works out to be squaring the r. You couldn't do u substitution with this problem, because if you chose to use the u as 9 minus x squared, the derivative of u is not in the problem. So we can't use u substitution. However, we can square the square root. It actually makes the problem easier to handle. So when we square that square root, we have 9 minus x squared. And what do we have left? Antiderivative. So don't forget to do the antiderivative. So keep the pi in the front, and then we've got 9x minus 1/3 x to the third, evaluated from 0 to 3. Maybe? So there's that pi in the front. That's nothing. 27 minus 27 over 3.
27 minus 9. So it's 18.
Okay. And then once you get your answer, go ahead and plug this into your calculator and just double check that it's right.
And you would plug the very, very beginning, right?
Mm-hmm. Yeah, whenever I check my answers, I don't plug in something that I've messed with. I plug in what I set up right at first.
Okay.
I will say that even though a lot of people take the pi and move it to the front, when I type it in my calculator, for me it feels natural to type pi r squared and just type the whole thing into the integral. The reason I'm showing you this is because in multiple choice answers, they typically have moved it to the front. So I want you guys to be able to recognize it. Okay, go ahead and try number 2 and 3, and then in a few minutes I'll go over one with you that does not revolve around an axis, so we can practice that, okay? It doesn't make it much different. It does a little bit, but it's not too bad. Okay, so aside from number 6 being an accident, this one you'll learn this later in the period, but number 6 you cannot rotate it around the y-axis with the disk method, which is the only method you know right now. So that was my fault. That shouldn't have been there. All right, for number 5, now we're rotating it around the y-axis. We're just going to use a calculator on this problem, so once we set it up, it's very quick. So I need to draw a picture. What does the graph y equals x cubed look like? Yeah, they call them the S curves. Yeah, so it's like kind of like half a parabola going up and half going down. And the line x equals 0 is the y-axis. And the line y equals 2 is what? Yeah, it's horizontal, up at 2. All right, so here's our shaded region. And we're rotating it around the y-axis, which means that our interval has to be in terms of y values, not x values. So what are the y values that we're going to use? 0 to 2. And we still have pi r squared, because we're still making circles as we rotate. So pi r squared dy. And we're going to do right minus left. And it has to be in terms of y. So can we do x to the third minus 0? No. We have to rewrite this equation. So right now I have y equals x to the third. How do I rewrite it so it's in terms of y? Cube root. Cube root. So x equals the cube root of y. So I have cube root y minus 0. So it's this curve minus this curve. Right minus left. The 2 is just a boundary. Okay? All right. What can I do with that exponent? I have a cube root of something squared. Cube root squared. So I want to rewrite that exponent as a fraction. Not 3/2, 2/3. So I'm going to take my pi, move it to the... Actually, you know what? Never mind. We're not doing any of that. We're typing it in our calculators. I forgot. These are calculator active. We're just plugging it straight in.
I love that.
Yeah. Going to do all this work. Pi cube root of... Now remember, when you type this in your calculator, it doesn't matter which variable you use as long as you're consistent. So if you want to type it in as y's because this problem was y's, you can do that. Just use your alpha key. Or if you are okay with doing everything in terms of x on your calculator, that's fine as well. It's not pi cubed, it's the third root. That's just how my calculator typed in the third root.
Oh, really?
Yeah.
I was like, what?
Okay. Okay. We're going to go ahead and jump down to the next one. All right, so for this one it says, sketch the area bounded by the equations and rotate it around the horizontal line. So if we're using a horizontal line, that's kind of like we're rotating it around the x-axis, right? Because the x-axis is a horizontal line. So is this going to be in terms of x's or y's? X's, okay? So in terms of x's, I have an upside down parabola. It says up to, and then it's upside down. Another line on the graph is the horizontal line, y equals 1. And this time I'm rotating it around the horizontal line, y equals 1.
So it's really like make your arrow on the axis.
Yeah, so this time it's going around here instead of going around the x-axis. I don't know. All right, I don't know what these numbers are, and so I'm going to say 2 minus x squared equals 1. And then what should I do? Move the 2 over. So I have negative x squared equals negative 1. X squared equals 1. So x equals, oh, be careful you don't kill anything. Plus or minus 1. Okay, no dead ducks here. All right, so we have the interval from negative 1 to positive 1 of pi r squared dx, and we have to do top minus bottom, and this time the bottom is not 0. This time the bottom is what? 1. So we're going to say 2 minus x squared minus 1. This is our top, this is our bottom. Top minus bottom. Okay? All right, that's ready to plug in. Go ahead and do that one. All right, let's graph number 8. What does number 8 look like? So just normal parabola, no transformations have happened to it, so just normal parabola going up. And then the line y equals 4, which is horizontal at 4. So here is our shaded region. And I need to see what my bounds are, so I'm going to set those two graphs equal to each other. I'm going to say x squared equals 4. X equals plus or minus 2. So my interval is from negative 2 to positive 2 of pi r squared dx. 4 minus x squared, because we have to do top minus bottom. So this time, the axis of rotation happens to be the top, and the curve happens to be the bottom. But we still did top minus bottom. All right, and that one's ready to be plugged in as well.
Where is it?
Did you translate?
Nah. I got legs and translate.
That sounds good.
I was like, I'm speaking to you.
It was.
I know it was on speaker, but
It
I
was
was
on
shaking. My mom was chill about it. I don't know what my mom sounded too chill.
My mom was like, we're gonna have a serious conversation tonight. I was like,
My mom was like,
All right. How are we doing on number 8? We doing okay on number 8? Yeah? Okay. So, what's the process for doing these problems? Yeah. Why is it important to graph it? Yeah, you got to see what your bounds are. Sometimes you can't see the bounds until you graph it. You have to know which one's on top and which one's on bottom. Okay, so graphing it is really important. Once you graph it, what do? Yeah, set up your integral. And if it's a calculator problem, you're basically done at that point, right? Just plug it in. If it's not a calculator problem, what do you have to not forget? You can't forget this step. Antiderivative. It's going to be really easy for you to forget that step once you get used to doing these in a calculator. Okay? All right, we're going to jump over to number 9. So these are the last 2 problems you have to do by hand in the entire packet. The rest are calculator active. Okay? All right. So this one says sketch the area. This time we're rotating it around the line x equals 4, which is a vertical line. And so if it's a vertical line, what does it have to be in terms of? Y. Okay, so on the front of my packet, I'm going to fix this. If it's rotated around the x-axis or horizontal lines, if it's rotated around the y-axis or vertical lines. So these 2 things I would put on my cheat sheet. And then I would maybe pick a couple examples from this packet just to write on my cheat sheet as well. Okay? And I would make sure to label this as the disk method. We're about to learn the washer method in a little bit. Okay? All right. Okay, so if we set this up, we have the graph y equals the square root of x. Does anyone remember what a square root graph looks like?
Like that?
Yep, goes up like this. So we have a square root graph. We have the line y equals 0, which is the x-axis. And we have the vertical line x equals 4. So that's this right here. And we're going to rotate it around this axis. This is our axis of symmetry. And so that means that our interval needs to be in y values.
So like from 0 to whatever that number is.
0 to whatever the y coordinate is up here. Okay. Yeah, we could plug in 4, right? If you plug in 4 for x, square root of 4 is 2 for y. So 4, 2 is that point right there. So that means our interval is from 0 to 2 of pi r squared dy. And we're going to do right minus left, and it has to be in terms of y. So it's going to be 4, because the right line, 4 minus the curve, but we can't use square root x. We're going to use y squared. So y equals square root of x. To make this in terms of y, I'm going to go ahead and isolate my x. So x equals y squared. And so that's what I'm plugging in. Okay. All right. Is this a good U substitution problem? No, because of the y squared. So that means we're going to have to write this twice, FOIL it out for when we do this by hand. Okay? I'm going to give you guys maybe like 2 minutes to work on that, and then I want to show us some washer problems before we leave. Okay? There will not be a video tonight. We're going to do some problems in class, and then we'll keep working on this. Okay?